My name is Abrar Salehin, and our team is uh, challenge based. Our team is Cyberwall, and our topic is challenge based authentication using zero knowledge proof. Let's first see the introduction part. Uh, um, uh, we are living in a highly digitized era that which signifies that our personal and sensitive information is more vulnerable than ever. The increasing interconnectedness of digital system adds layers of complexity. The task of safeguarding this information. Various digital platforms and services collect data and store user data, making the landscape challenging to navigate. We are leaving our footprints everywhere. However, in this digital user authentication is user acts as the digital gatekeeper. User authentication plays a pivotal role as the gatekeeper to the digital space, ensuring that only authorized individuals gain access to sensitive information. However, this gatekeeper role is constantly under threat from sophisticated attacks such as man-in-the-middle attack and phishing attacks. Man-in-the-middle attacks involve intercepting and eavesdropping on data exchanged between users and systems, while phishing attempts aim to deceive users into revealing sensitive information. Other than two attacks, there are thousands more attacks that hackers are trying every day to hack into users' account and steal sensitive informations. Um, so we are introducing a challenge-based authentication system, and which is different from traditional authentication system. So let's first see the traditional authentication system. At first we talk about password based. We all know that for log into any anywhere, we have to use our username and password. Don't forget, we input our password as plain text, right? It has in the backend, but we when we input it, we input it as plain text. This is general password based authentication. And multi-factor authentication, it's two-factor authentication. You can say that when we want to log into any system, from the system we get a OTP in our mobile phone, and then from there we get a four-digit number, and we have to put that number in the system to log in. That's multi-factor authentication. Biometric, we all use iPhone, or even in the Android we have fingerprints option. So biometric is, we all know that biometric is token based. I think everybody is familiar with WhatsApp. When we want to log into WhatsApp web, we have to scan our mobile. So the scanning part is it's kind of the the QR code is kind of token. So we are authenticating the web browser from from our mobile phone to use our WhatsApp account. So this is a token-based authentication. These are some basic authentication techniques, but we are introducing a new challenge-based authentication, and
In order to test our idea, we use several effective and efficient development tools. The next is a comprehensive full stack framework. At the heart of this project development lies Nest.js, a highly regarded and advanced full stack framework that has generated substantial recognition within the web development sphere. JavaScript, the ubiquitous programming language. JavaScript was designed as the principal programming language for this undertaking. CSS, a streamlined approach to styling to cater to the project's user's interface and styling prerequisites. We embrace the CSS. And finally, we use the Visual Studio Code IDE to develop our project. About the workflow for our project, the first step, user enters their username. The second step, user is presented with a random alphanumeric change key, for example, HF75JJ4, and then user concatenated the challenge and his password like this: HF75JJ4 at password equal to HF75JJ4 password. The fourth step, user create a SHA-246 hash of the concatenated string. Finally, user use that SHA-256 hash to login.
All know our authentication system is based on zero knowledge proof. But what is zero knowledge proof? In simple terms, zero knowledge proof is like uh, proving that certain piece of information is true without actually revealing that information. It's like I am saying that I know a secret, but I want to convince you, I want to prove you that I actually know a secret, but I won't tell you the actual secret. I will convince you somehow that I know the secret. We are using the same approach, same method in our authentication application, in which we are convincing or we are proving to the server that we actually know the password, and we are not providing the actual password to the server. So by not providing the actual password to the server, we are mitigating the phishing attacks, man the middle attacks, and the privacy concerns related to passwords. Let's move ahead and I will show you a quick demo of our project. This is our project, which looks quite similar to a normal login screen, but it is different. Uh, so basically, as every login authentication mechanism, we have to enter our username. For this case, like Uzair, and I have to submit my username, and it will provide me with the alphanumeric key, which is a challenge in this case. I will copy this challenge and create a SHA-256 hash of this challenge plus my password, which is in this case is secret pass. This is for your explanation, but we just have to concatenate these two strings. So it should look like this. And now I have to copy the output hash that's being provided. And then I have to put it in the response. And then I have to click the login button. And we are logged in. Let's try it one more time, but I will provide a same hash, but I will change some part of it. And let's try it. And it says it's wrong. The response is wrong. What if I provide the actual password? It will still say wrong bit because it need a response. We need to solve this challenge to actually log in. And every time, every time I actually try to log in, the challenge will be different. So it is totally randomized. The only person who actually knows the password will be able to log in. Okay, let's try this challenge. We will just remove the previous challenge with a new one and then calculate a new hash. This is the new hash. I will copy it and paste it over here. And we are logged in. So that was the demo of our application, which is using zero knowledge proof underneath. And like there are different authentication mechanism available in the market. And recently Google has also introduced authentication mechanism known as passkeys, which is quite not quite similar, but kind of addressing the same problem. Uh, but it has its own downsides. Our authentication mechanism has its own downsides, but as I was talking about Google Passkeys, it has its own downsides, more of a device dependent type approach, and you are using your device lock to actually uh, log into all of your accounts. So that's all from our side. If you have any questions, please feel free to ask. And thank you so much.